Hello Minecrafters and welcome back to another redstone video. This is episode 4 of learning redstone computer with Minecraft. Yes, I did not forget about this series, okay? I was just too busy to make any sort of videos. As you can see on my channel, the channel is kind of dead right now. But I'm back and I want to make a lot of redstone videos. Hopefully, I'm still very busy in the summer, but I hope that I will be able to have just enough time to pump out more videos for all of you to enjoy. So far in our series, we have made an LRU and a register file. The LRU is an 8-bit LRU and it has a bunch of operations over here ranging from just simple addition subtraction to bitwise logic operations. For register file, we have dual read register file, meaning there are basically two sides of this register file. We also have a write function here, a clock signal to input the data into our desired register file. We also have the coordinate system here to select the corresponding register file that we want, and we also have some outputs to read the data stored in the register files. In today's episode, we were gonna follow episode 4 of Mattbatwings series, and we were gonna learn about assembly language. We also gonna learn about machine code and how to combine the LRU that we have with the register file alongside a thing called control ROM, so we can actually design a program in today's episode. So with all of that out of the way, just sit back, relax, open up Minecraft, and together we were gonna design something really cool today. So yeah, let's get right into today's episode. First thing that I need to do is to upgrade this register file, because 8 register files, 4 for each side, is not gonna be enough, especially for this LRU. So I will gonna expand this register file to 16, similar to Mattbatwings register files, so we can do even more insane stuff with the register file and the LRU. So I have finished upgrading the register files that we have here. As you can see, it's a bit longer now. That's because I added more register files. So instead of 8 like the previous one, this one has 32, 16 for each side of the reading part. And in order to access all of the addresses, I have to upgrade the addresses selector over here. So instead of just 2 bits, I have to use 4 bits in order to access all 16 addresses of the register files per side. So this is the first side of the register file, and this is the other side. When combined, we have in total 32 different addresses that we can use for our computer, which is really nice. Now the way that I encode the stuff is very similar to the last episode that I showed to all of you. I just expanded a little bit more. So if you don't remember how I did it, you can rewatch the video. I will not gonna talk about it in this episode, because that's not the main focus of today's episode. The next thing that we need to do is to connect the LRU that we have here with the register file that we have here. And in order to connect them is very easy. We just have to follow this diagram right here. We can see that the output of the register files, so these two outputs right here, these two 8-bit outputs, will go into the inputs of the LRU, and the output of the LRU, which is this yellow part right here, will go into the right part of the register file, which is this gray part right here. So all I have to do is connect these two brown lines to the orange part of the LRU, and I connect the output of the LRU, which is this yellow circuit part right here, with the gray part of the register file. So yeah, let's do that. So I have connected our register file with our ALU. Now we can do some pretty interesting programming, and I'm gonna show that to all of you. Let's say I want to store number 3 at register number 1, number 7 at register number 2, and then I'm gonna add 3 and 7 together, and the result of that addition will go into register number 3, for example. So yeah, let's try to do that. First, we need to enable our register file for it to work. Then we're gonna input number 3, and we're gonna select register number 1, and then we hit clock signal so we can store number 3 at register number 1. Then I'm gonna input 7 here, and then I'm gonna input register number 2, and I'm gonna hit the clock signal so we can store number 7 at register number 2. Now in order to do addition, we're gonna use our LRU, and to do that we need to feed 3 and 7 to the input of our LRU. So I'm gonna read register number 1, which contains number 3. I'm gonna read register number 2, which contains number 7, and the result is 1010 or 10, because 3 plus 7 equals 10. Now I want to store this number at register number 3, so I'm gonna select register number 3, and then I'm gonna hit the clock signal, and if we go to register number 3, we can see that we have 1010, which is 10 in binary. So we have successfully stored number 7, number 3, which are our input data, and we have successfully stored the output data of the LRU, which is 10. The next thing that we need to do is we need to build a control ROM which will allow us to input data into our register file alongside choosing an operation of our LRU much easier. The way that I'm gonna encode our control ROM is by following Mattbatwings spreadsheet. I will link that in the description. Currently, the spreadsheet in episode 4 of his series only has in total 6 instructions, so I will only gonna be encoding 6 operations according to episode 4 of his series. Okay, what the control ROM allow us to do is it will take in a 4-bit binary input, and it will output the operations that our LRU has that we want, and also enable our register file. So it's actually really easy to build because we have our basically our encoder here for our LRU. Now we only need to build a decoder which will decode a 4-bit binary string to one of these options, and we also gonna wire those output to the enable input of the register file. So yeah, let's do that in time-lapse form so you can see how I actually did it. Okay, some progress update. I have moved all of the inputs of the register file to over here so we can operate the register file and the LRU much easier. So here's the data input, here's the read
for the right side of the register file. Here's for the left side. Here's the clock signal, and here is where we can select the addresses of all of the registers in our register file. We also have this decoder right here, which allow us to select an operation in our LRU. However, I want to make it as closely to Mattbatwings instruction set or the Excel spreadsheet as best as I can. And with the current implementation of the lamp circuit here, it's a bit wrong. So what I'm gonna do is I'm gonna change things a little bit. So I'm gonna basically separate the carry-in, which is this part right here, with the like the inverted B and A option, because in Mattbatwings spreadsheet or the instruction set, he separated both of them. So both of them are like separate inputs instead of what we have right now. So yeah, that's basically what I'm gonna do, and I'm also gonna redo this lamp circuit a little bit so it acts more like a control ROM rather than this, because right now the decoder doesn't quite work. But yeah, that's what I'm gonna do next, and I think that should be everything done for this episode. So yeah, just sit back, relax, and let's finish our control ROM. Alright, so here is our control ROM, and this control ROM has 1, 2, 3, 4, 5, 6 operations. Of course, we can expand this further because we have 4 binary bits, which means we can have up to 16 different operations. But for now, I only have 6. We can always add more if we need. I have also added some data into our register file. So at register number 1 we have a number 3 here, and at register number 2 we have a number 2 here. Now we can do some pretty interesting operation with these two data. Let's try adding those two numbers together. So first we're gonna enter our operation code, which is these 4 bits right here. And for addition, it is number 2, so we enter 0010 into our control ROM. Next, we're gonna input the addresses for our 2 numbers. So I remember that number 3 is stored at register number 1, so let's see. Yes, and at register number 2 we have number 2, so let's check. Okay, so we have 3 on our right side and 2 on our left side of the LRU. Now we can do addition. Since we have selected addition here, we can go to the clock signal. Oh wait, we also have to select a address for the result of the LRU to be stored. I'm just gonna leave it as 0, so we're gonna store the result of 3 plus 2 at register number 0. So now if I hit clock, in theory, if we go to register number 0, which is this one, we can see 5. 101, so that's 5. We can also do some other insane stuff. For example, if we want to subtract, so we want to take 2 minus 3, we can also do that by selecting the subtraction operation. And now we're gonna continue store the result at register 0. We were now gonna hit the clock signal, and we should see -1 at register 0, and this is actually correct. This is -1, but it's a 2's complement like version of it. Alright, let's try something else. Let's say I want to do some bitwise logic, like n for example. So for n, I need to select, I think that's 5, yes, 5. So we select 0, 1, 0, 1 here, which means we have selected n operations. Now we were gonna go to the clock signal, and in theory we only gonna have the second bit lights up and not any other bits. So let's hit the clock signal, go to register 0, and we should see, yep, only the second bit is on. The rest of the bits are off because that's how AND gate works. And finally, I think we can try the red shift. So I'm gonna select 7 because that's for the red shift operation. I will now gonna hit clock. Oh wait, for red shift I have to delete basically one side of the input needs to be 0, so I'm gonna select, I don't know, like register 3, because register 3 has 0. So now we're gonna shift this number up or to the right. So if I hit clock, we should see at register 0, yep, the number 3 has been shifted up by 1 or shift to the right by 1. So now we have 6 instead of 3, because if you don't know, if you shift a binary number to the right, you kind of do a multiplication by 2. You double it, like 3 double it is 6, 6 double it is 12, and so on and so forth, which is really interesting in my opinion. And yeah, that's it for today's episode. I think we have done a lot of progress in our journey to making a redstone computer. Of course, we are only at episode 4 of my Mattbatwings series, but I will try my best to continue this series as like as fast as possible. So like I will try to make another video really soon, because I really enjoy doing this, and I hope that you do as well. So yeah, thank you very much for watching. If you have enjoyed today's episode, you can like, comment, and share this video around so more people can know about the amazing world of redstone computers, and maybe potentially we will able to persuade more people to build redstone computers and to understand more about computer architecture. I think, I don't know, but it is cool, I think. Again, thank you very much for watching. Like, subscribe, do all of that to support your local redstoner, and I will see you all in the next episode or another redstone video. Have a nice day, everyone.